All right, now we've got our new friend here that allows us to convert these very odd numbers for watts per meter squared into decibels. So by using the reference level on the bottom, IO, and again this is for human beings, we can place the number we know in watts per meter squared on top, work the math through, and then we get these nice numbers that come out 20 decibels, 90 decibels, 100 decibels, etc., etc. The only negative that we have here is this log function, and some people are not as comfortable with logs. Now let's try to do the reverse process. Let's suppose we're given the decibels, and then I ask you what is the actual value in watts per meter squared. So we've got to be able to work backwards sometimes. So let's say, for example, we start out and we have a value of 70 decibels. That equals 10 log. And then over here, the I value is unknown. That's what we're trying to find in watts per meter squared. We know that the bottom is 1 times 10 to the minus 12th watts per meter squared because that's our reference level for human beings. Now, anytime I do these log problems, I can't remember how the log things work. You know, I go like, oh man, these things were a pain. Now in math, I remember there used to be like, different bases to them. So, when there's nothing written here, we know that it's actually in base 10, so we don't have to worry about all those unusual logs. All right, now, what I usually do is make up some type of, a simplified one, and then this way I can remember how to use the logs. So I say to myself, what is, say, log of 100? So if I go through there, I said, what does that actually equal? I actually know that. So the log of 100, if I do that, is equal to 2. How do you get 2 from 100? It doesn't seem to make any sense here, So then I recognize the fact that when I take this is the exponent when it's a base 10 operation. So if I take this, 10, and then I put the number here above that, it gives me back the value that's after the log. So if we look here, the log of 100 is 2 because 10 squared is equal to 100. All right, now if we tried something else, let's try log of, say, 1,000. So log of 1,000, put it in my calculator, I end up with a 3. How did I get a 3 out of it? Oh, it's the exponent. So 10 to the third is equal to the number that comes after the log. All right, now let's go back to our original problem here, 70 decibels, and I'm trying to work backwards and convert that into watts per meter squared. All right, now notice in this problem here, and in the formula itself, there's a 10 in there. The 10 was put in there to make the numbers more comfortable for regular folks. All right, so I've got to get rid of the 10. I'll divide both sides by 10. So 70 divided by 10 equals 7, and then I'm left with the log of whatever this thing is inside the parentheses. All right, now remember, this is the exponent. So if we take this, 10 to the 7th is equal to what? It's equal to the number inside the log symbol. So that, whatever it is going to be equal to 10 to the 7th. Well, what is the stuff inside the log symbol? Well, I can get rid of the x here, and let's put what's actually inside there, and the answer is I divided by 1 times 10 to the negative 12 watts per meter squared. All right, now if I multiply this out, 10 to the 7th times 10 to the negative 12th, we recognize the fact that I is going to end up being equal to 1 times 10 to the, and if we multiply here, we add them, 10 to the minus 5th watts per meter squared. So we now have our answer. How loud is something that is 70 decibels? And the answer in watts per meter squared is 1 times 10 to the minus 5th watts per meter squared. So we've got a way of converting either into decibels, working that direction, or working our way backwards.